Good morning, everyone. My name is Sudhanshu Sharma, and I welcome you all to this webinar of flip flops. Me and Karan Sharma will just let you know each and everything about the flip flop in today's webinar. So please tighten up your seat belts and let's get started up with the webinar on the topic flip flops. So what we are going to cover in today's webinar is what actually flip-flop is, what is the difference between latch and a flip-flop, what are the types of flip-flop, how can construct the flip-flop using logic gates, and at the end of the seminar, we'll give you the proper demonstration of each and every flip-flop where we will verify each and every truth table of all the flip-flops. So let's not waste some time and let's get started with this webinar because this must be so long and I don't want it to take so long. And I would, before starting, I just request you to please kindly focus on the screen and just listen to each and everything what I'm going to say, because the major aim of this seminar is to overcome. I've created this seminar as per the students who are going to start understanding flip-flop, who are going to start understanding the flip-flop for the first time, or have already learned the flip-flop once but have confusion. So this seminar will overcome all the confusion which usually students have while studying it for the first time. And this is what I want to say. So let's get started. What with the question, what is flip-flop? Actually, if someone asks us what is a flip-flop, so how we can define it? Basically, to the point that flip-flop is a memory storage element. That's all. Flip-flop is a memory storage element, and एक memory storage element क्या होता है? In a memory storage element, we can just store something. So the special capability of the flip-flop is that it can store, yes, but it can store one bit at a time. Either it is 0 or either it is 1. So flip-flop is a memory storage element. We can store bits which can either at one time, one bit at a time, either it can be 0 or either it can be 1. I think it is clear what flip-flop is, and let's move forward for the things which will make the understanding of the flip-flop much clearer if you understand this topic. Like, what is the difference between sequential and the combination circuit? Both of these are the circuits, but what are the major difference between these so that we can understand flip-flop in a better way is that sequential circuit we apply feedback, but in combination circuit we don't apply feedback. Just focus on just one thing, feedback. In sequential circuit we provide feedback, in combination circuit we don't provide feedback. And the main thing is that what we are studying in this seminar is what we call sequential circuit. Flip-flop latches are the sequential circuit. But now the question arises is, yeah, we know that what is flip-flop, we already discussed in a previous slide, but what is a latch and what is the difference between them? So for overcome this confusion, just focus on the one thing, that latch and flip-flop are altogether same thing which can store memory. Okay, but the major difference is that in latch we do not provide clock pulse, but whereas in flip flop we provide clock pulse. So till the end of this slide, you can just get to know about what flip flop is, and flip flop a sequential circuit in which we provide feedback, and flip flop are the thing in which we provide clock pulse. Now all these things will help you out in understanding the construction later on. So let's discuss about what are the types of flip-flop, which is the most important part of this seminar. So the first flip-flop in our list is SR flip-flop, then second is JK flip-flop, third is delay flip-flop, fourth is toggle flip-flop. For JK, I would like to add something that JK is an updated version called master slave JK flip-flop, but we here only take JK flip-flop because JK flip-flop and master slave is all together, but master slave flip flop is the updated version of JK flip flop. So the broadly, if we classify the flip flop, we have four flip flops. So for every flip flop, first we'll discuss about the construction of the flip flop, and they'll discuss some important parts of that flip flop. So now we are going to understand the SR flip flop construction, which is from my side it very much interesting, but all the way it's confusing because I saw students just cram while looking into the book that how we can construct a SR flip-flop. But I will assure you that if you focus on the screen, you will get to know about the real construction of SR flip-flop, how can construct it. Because if you understand the construction of SR flip-flop, then you can understand the construction of each and every flip-flop in a easy manner. So before starting with the construction of the SR flip-flop, I would like to tell you that for constructing SR flip-flop, we can construct the SR flip-flop in two manners, either using the NAND gates or using the combination of an AND and OR gate. For this seminar, I am going to construct each and every flip-flop using NAND gates. So let's get started with this. So for constructing SR flip-flop, we need four NAND gates. After that, we have to give input, and by the name suggested as a S and R, we'll give the input S for G1 and R to G2. The other thing is that we already discussed that in flip-flops we provide clock pulse. So we provide clock pulse, that is from G1 and G2, and then the clock pulse. Now we have to give the output of G1 and G2, which will act like input to G3 and G4. And the next step is to give the G3 and G4 output as Q and Q bar. I think this is the simple thing which you actually understand. Now the last and important point is that we have discussed in a previous slide that flip-flops are sequential circuit, and in sequential circuit we provide feedback. So what feedback is? The feedback is here what I'm going to show on the screen. That I just give the feedback for G4 output as the input to the G3, मीन्स उसका आउटपुट उसको इनपुट दे रहा है, मीन्स ये जो फ्लिप फ्लॉप है ये अपना फीडबैक दे रहा है G3 को, एंड इन द सिमिलर वे the G3 output will give the feedback to the G4, and with this we have done with the construction of SR flip-flop. Is so very easy. So let's understand about SR flip-flop and just focus on the truth table which is beneath this. So SR flip-flop is the basic building block. We can just set and reset the data bit. Now focus on the truth table of it. For 0 and 0 will get Qn minus 1, that is the previous state. For 0 and 1 will reset the flip-flop. Reset means to start everything from the 0. So the output will be 0. S set, तो set अपना दिमाग सेट कर लिया हमने, will start everything with day 1, so output will be 1. But the disadvantage is that for 1 and 1 SR flip flop की जो disadvantage है, for 1 and 1 output, that when S and R both are 1, it will not give any output, and this is the only reason that we come on the construction of GK flip flop. So let's get started with the construction of JK flip flop. The JK flip flop is similar to SR flip flop, but we just change it a little bit. We have 4 NAND gates, but instead of S and R input, we'll give J and K input, and then we'll give the clock pulse as we have given in SR, then give the output from G1 and G2, which will tend to look like an output input of G3 and G4. Then we'll give the output of G3 and G4 as a Q and Q bar. After that, we'll give the feedbacks, and it's the same as SR flip-flop, but here the thing is that here instead of S and R we give the input J and K. So the last thing which is to makes SR flip-flop different from JK flip-flop is this: will give the extra input G1, which is the output of G4, means G4 is giving the output feedback to G1, and similarly G3 will give the out feedback to G2. So the third input of G1 and G2 is what the difference between SR and JK flip-flop construction. It's so very easy. I think you have understood. So let's get started on the next screen. That is the same as SR flip-flop, but overcome the problem of invalid state in previous flip-flop. As I've already told you, the JK and SR flip-flop is totally same, but we just do some updation in SR flip flop by doing two more feedbacks, and we'll just overcome the invalid state disadvantage. So for 0 and 0 in the truth table we have the same thing. So 0 and 1 with the same thing as SR, and for 1 and 0 the same thing as SR, the same output as SR, but the difference that for 1 and 1 there it is invalid, so here it is the opposite of the previous state. That's all. But I would like to here add one more thing, that even now the JK flip-flop is showing the output on 1 and 1, but it has a disadvantage that it is just toggling the input so very fast that it is not able to just remain at the input for a more particular time, and that will said that it's a race around condition problem in JK flip-flop, which makes us to construct a master slave JK flip flop. JK flip flop और master slave flip flop are both the same, दोनों flip flop बिल्कुल सेम है, बट ऐसा हुआ कि जेके फ्लिप फ्लॉप में हमारे पास रेस अराउंड कंडीशन आई, इसलिए हमने मास्टर सेफ जेके फ्लिप फ्लॉप को बनाया और हमने वो रेस अराउंड कंडीशन को ओवरकम कर लिया, एंड हमारा पूरा जेके फ्लिप फ्लॉप पूरा बन चुका। इसको हम प्रॉपरली अंडरस्टैंड फिर से करेंगे जब करण शर्मा आपको डेमोन्स्ट्रेट करके दिखाएगा, तो आपके जो भी डाउट्स होंगे वो वहां पे प्रॉपरली क्लियर हो जाएंगे। So let's jump on to the next flip-flop, which is construction of D flip-flop. Now you think at why I have put the SR flip-flop on the screen, because I would like to tell that for D flip-flop we can construct the D flip-flop from the S flip-flop, SR flip-flop. It's the same as SR flip-flop, but we just I'll do the just minute changes, and we'll just have RD flip-flop. First of all, I'll remove these S and R input. First of all, I remove these S and R input, and then I'll just give the common input as D. But the point to be noted here is that we are giving the common input, but here we add the inverter, not gate. That if we provide 0 to G1, it will automatically invert it and will provide it will give the out input 1 here. If we 1, then it's 0. That's all. We just have update little bit of SR and we are able to create D flip flop. That's why I told you that SR flip flop you understand, which is even easy. You definitely understand about D flip flop. D flip flop we can also call this a data flip flop. It's also named as delay flip flop, and we can also call this a data flip flop. It's used to create delay lines which are used in digital signal processing. Then if we focus on the truth table of it, then for it the true D flip flop की truth table सबसे आसान होती है, 0 for 0, 1 for 1. That's all. But the important thing for D flip flop is that the flip flop, this flip flop can construct using both SR flip flop or JK flip flop. In the previous slide I made it using SR flip flop, but you can also made it using JK flip flop. Okay, so now the construction of T flip-flop, it is also the same, but here I have took JK flip-flop, and I would like to tell you that it can only be constructed using the JK flip-flop. So it's a JK flip-flop on the screen. We'll just do the minute changes and will construct T flip-flop right in few seconds. First of all, I will remove J and K input. Then I'll give the combined input T. That's all. That is it. Our T flip-flop is now constructed, and we can just go on to the next slide. So the for T flip-flop, as you have already seen, we can design the T flip-flop by making simple modification to the JK flip-flop. The flip-flop act as a toggle switch. So what do you mean by toggle? Changing the next state output to the complement of the present state output. It means अगली जो स्टेट आएगी उसकी वो उसको इंस्टेंटली चेंज कर देगा. इफ 1 है तो 0, 0 है तो 1. And if you are not able to understanding this thing at this time, I will assure you that when we just give the demonstration of this, especially toggle flip-flop, you will get to understand each and everything what toggling means. So the truth table for 0 will have Q1 minus 1, that is the previous state, and for 1 we have toggle. Means जब 1 वैल्यू आपकी हो जाएगी इनपुट पे, तो आउटपुट पे एक क्लॉक पल्स पे 0 होगा, एक क्लॉक पल्स पे 1 होगा. ये आपको क्लियर हो जाएगा, हम डेमोस्ट्रेशन आपको करके दिखाएंगे। इंपॉर्टेंट थिंग अबाउट टी फ्लिप फ्लॉप इज द टी फ्लिप फ्लॉप आर नॉट अवेलेबल एज आईसी। ये मुझे भी नहीं पता था। व्हेन आई एम प्रिपेयरिंग फॉर दिस सेमिनार, देन आई गेट टू नो अबाउट दैट टी फ्लिप फ्लॉप की कोई आईसी नहीं होती, वी जस्ट क्रिएट इट यूजिंग द मॉडिफिकेशन ऑफ this GK flip-flop. So the main disadvantage of the T flip-flop is that state of flip-flop at an applied triggered pulse is also can only be known when the previous state is known. अगर हमें previous state का पता होता है तो हम अगली state को उस ट्रिगर्ड पल्स पे क्या होगी तभी हम पता कर सकते हैं। अगर आपको अभी नहीं समझ आ रहा, कोई दिक्कत नहीं है, आपको ये सारी चीजें अंडरस्टैंड हो जाएंगी अब आने वाले टॉपिक पे, दैट विल लीड बाय करण शर्मा। now I will hand this is the end of this my presentation. I will discuss each and everything about flip flop, and think I hope that every your confusions regarding the flip flops is just gone. So I would like to request Karan Sharma to present his screen and let you give the feel, a sense of how flip-flop actually works by demonstrating and verifying the truth table. Thank you for the time, and I will see you after this demonstration. Thank you, everybody.